Okay, guys, let's go through these. Okay, so the first one, sine of 3 pi over 4. I got to know where 3 pi over 4 is. Where is it? Second quadrant, right? Right in the middle. I care about the y value. What's the y value there? Okay, done with number 1. We okay with that? All right, cosine then. 11 pi over 6, where's that? Yeah, right here, okay. I care about the x value. What's the x value? Okay. Are you 2 for 2?
Yeah.
Yay. Now tangent, okay. All right, where's 2 pi over 3? Second quadrant, it's right here, okay? The ordered pair there is negative 1/2 root 3 over 2. I care about both of those when I'm doing tangent. Now, guys, we're going to work through, like, dividing those a little bit more today. There are shortcuts to these, but it's all so new to you that if I show you the shortcuts, you're going to just be like, what madness are you writing on the board right now? Like, it won't make sense yet. So we'll practice it a little bit more, and then I'll keep giving you little, like, hey, these are always this value. Like, you'll start to see the patterns. But it's still pretty new right now. So I'm doing y over x, so that'd be root 3 over 2 divided by negative 1/2. That's the same as multiplied by negative 2. So it's just negative root 3. How'd we do? Hitting it? Okay, good. All right, cosecant. You certainly can do 1 over the y value. I like to think of the sign and just flip that rather than like the 3-level fraction, but whichever makes sense to you is fine. So if I go to 5 pi over 6, which is over here, if I think about the y value there, like the sine of 5 pi over 6, that's just 1/2, right? So what happens when I flip 1/2? Okay. All right, secant. Pi over 2 is up here. What is the x value up there?
0.
Yeah, so the cosine of pi over 2 is 0. Guys, what happens when you flip 0? Undefined, good. Because really 0 could be written as 0 over 1. So when I flip that, I get 1 over 0, which is undefined.
So you just want 0.
Yep, and you can abbreviate it, that's fine. Okay, then cotangent. 5 pi over 3, that's down here. Let's see, so the x is 1/2, negative root 3 over 2. All right, I'm doing x over y, so 1/2 over negative root 3 over 2, that's going to be times negative 2 over root 3. That ends up being negative 1 over root 3. When you rationalize it, what do you get? Negative root 3 over 3. All right, how'd we do? Pretty well? Okay. Are they getting a little bit better? Guys, we're going to do these like the rest of the year, basically, okay? Even when we get into the calculus stuff, I'll throw a, hey, do these 10 trig values at you, okay? Yes, but you're going to get to a point where you're like, oh, cotangent 5 pi over 3, that's negative root 3 over 3. Like, you will not be writing all of this the whole year. I promise. Come on. Doesn't matter. Neil, did you have a question? Are you sure?
Yeah.
Okay. Yeah.
For 6, can you just go over 6 again?
So I did the x over y. And dividing by this means multiplying by the reciprocal.
Okay.
Simplifies to that. I have to rationalize. Which gets me to there. No. Here, these reduce, and then I rationalize. Okay. All right, guys. We're going to start our notes. Notes. Okay, we are graphing today, guys. You don't need graph paper or anything, but we are graphing. I'm going to draw just a little circle over here on the side to reference. And then guys, that's all I'm drawing for the graph. Like, you just need essentially an x and a y-axis. And yes, the x-axis should be longer than the y-axis. Okay. The first thing we're going to graph is y equals sine of x. We are actually going to make a little table of values for our x and y. The x is actually representing an angle. Okay, that's the like pi over 2 or 2 pi over 3 or, 150 degrees. That's what x is. Y is then the sine of that angle. Okay? So of whatever angle you pick. So guys, what is the angle right there on the circle where that blue dot is? 0, right? That's 0 degrees, 0 radians. Yes? Okay, so the x value there is 0. That's the angle we're talking about. Okay. What's the ordered pair for that point? 1, 0. Okay. So what is the sine of 0 degrees or 0 radians? Whatever we're talking about. 0. Okay, that's a lot of zeros. So that is the point 0, 0 on my graph. All right, I'm going to go up here to pi over 2 next. So that's the angle I'm talking about is pi over 2. What's the ordered pair up there? 0, 1. So what is the sine of pi over 2? 1. So on my graph, I'm just going to make a little tick mark and label it as pi over 2 on the x-axis. And then I'm going to make a tick mark and label it 1 on the y-axis, and that's where my dot goes. Stick with me while we do each one, and then at the end you'll go, oh, okay, I get it. All right, I'm working my way around the circle. What angle is over here on the left? 180 degrees, what is it in radians?
0.
Pi. 0's on the right side. Pi is no, I asked for the angle first, okay. You're right, the sine of pi is 0, yes. So on my graph, I go the same distance away, I make another little tick mark and label it pi. The sine of pi is 0, so I put a dot at 0. This was negative 1, 0, I guess we never labeled it. All right, down at the bottom, what angle is that? 3 pi over 2. It is 270 degrees. We're doing radians right now, though. So 3 pi over 2. The ordered pair is 0, negative 1. So what is the sine of 3 pi over 2? Okay. So on my graph, I need another tick mark. That is 3 pi over 2. I now need a tick mark of negative 1 on the y-axis. I can put a dot down there. And then we have one more to do. If I make it all the way around the circle, what angle is that? 2 pi. What is the sine of 2 pi? 0. Back where we started. Okay, so that's 2 pi. Back to 0. All right, let's stop there for a second. It is, yeah. These graphs are periodic, meaning it's going to repeat the exact same wave over and over and over a specific period of time, okay? So it takes from 0 to 2 pi to see one cycle of this graph.
So it just keeps going around the circle.
Yes, that's why it repeats, because you just keep going around the circle. All right, I'm going to connect these. When you connect them, they are not connected with a straight line. Think about what we just sort of unwrapped over here. It was a circle, right? It is curves that connect these. So this is what your graph looks like. It's a wave. Okay. And it will follow this pattern over and over and over. We're also going to draw the left side of the graph. Okay, the labels. The right side was pi over 2, pi, 3 pi over 2, and 2 pi. The left side, what do you think it's going to be? Negatives of those, yes. So negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. Now, to get the points, you can absolutely actually go to your circle and go backwards around it. Or let's just kind of look at the pattern. If I start over here on the right end, I see 0, negative 1, 0, 1, 0, negative 1, 0, 1, 0. You guys see how it's just going to follow that same pattern, okay? So guys, that is your parent graph for sine. We're going to graph doing a whole bunch of transformations to that parent graph, okay? So you've got to know those original points and be able to reproduce those, okay? Anybody questions on any part of that graph? Are we okay with the left side? Are you guys good with that pattern? Just following the pattern? And secant and cotangent, yes. Today we're just going to do sine and cosine. And then, I don't even know when. Next week is such a mess. Maybe next Friday is when you'll get another day of actual learning. So then we'll do tangent, cotangent, secant, okay? Once you get the idea with sine and cosine, the others aren't hard. Okay, you guys are going to try to graph cosine. So, like we just did. Think about the circle if you need it. Make a little table if you need it. This one I think is harder for you to see. Remember, x is the angle. Y is what cosine of that angle is, okay? You mix up like your x and y's on this one, so try to graph it. Same labels as we used for sine. Give you a few minutes to try. check in with your neighbor once you've got it. You don't know your cosine. Realtors with that.
So it's like, traffic,
I know.
and
Everyone.
it's the problem.
Yeah.
I don't want to do at all.
You have to start at one. Literally, you start at one for those numbers.
Because what's the cosine?
Okay, that's the 1.10.
Yeah. Yeah, that's good. It's, so I actually have a bunch of applications, I'll show you videos. I actually have one. Some of the things that would be called zero cards. So far, oh, and you can use it, yeah.
Yeah.
But it gets used all the time.
Oh.
It is, yeah, it is a lot.
I still have to get one. Taking an exam.
Yeah, it's fine.
What is the I'm right here. That's evaluating.
Why can't I just be like,
It's like close to that.
go down, go down, go up.
I like how you know that it's I can't help it. I mean, it's really useful actually to help that.
Actually, it's like that. This balance, it's not.
Yeah, but you're just learning how to roll. It's so late. It would look like this, right? Like it's not balanced.
I felt
Like an ice.
You're just looking at this. Like this is supported with that.
Yes, now,
Down, 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 down.
or just
Is that balance, right?
so I've done. I used to do I did it I just remember and I felt bad. I got it, so it's nice to say myself
That sounds very good. I did with my time COVID. Are you good now? It's never gonna
That's what I actually got.
Alright, let me put it up here, guys. Alright guys, there's your cosine graph. These two parent graphs. Guys, you have to know these dots. You have to know the position of the dots. We're going to do all sorts of weird stuff with the labels on your axis and all sorts of shifting and different transformations. You always need to start with the dots in these spots, okay? Like, no matter the labels before you begin, you need to know, oh, okay, cosine, and you should be able to just put those dots in this position. Then we'll change all sorts of stuff, okay? All right, so you've got your two parent functions. Let's now talk about all of our transformations. So standard form for a trig graph, y equals a sine of b x minus c plus d, okay? Those are the four things I could change for you. You know what most of them are already. You do, you guys know things. I promise you know things. It's transformations you've been doing, right? I'll tell you. Piper? Hold on, I can't hear you. Guys. Piper, what? Yes. Yep. So if it was a cosine equation, it would obviously say cosine instead of sine. But yes, same A, B, C, and D. Okay, guys, think about all the graphs you've done before. If you had a number out in front where the A is, what would that do? Vertical stretch, right? Okay. So A is a vertical stretch or compression. Along with that, the absolute value of A is called the amplitude. Okay, guys. B, The coefficient on x, what does that do? Yes, that is the horizontal stretch or compression. Yes, but I'll show you how we're going to use it. Because everything's in radians on your x-axis, it's a little trickier for you. So this one will change the period. I know you don't know what the period is yet, but it changes the period of the graph, okay? I'll give you a picture at the bottom here to sort of label all of these things. For the amplitude, yes. All right, guys, what do you think C is? Yeah, that's your horizontal shift or transformation. It's also sometimes called a phase shift with trig graphs. I might ask you in a question like, here's this graph, what is the phase shift? So I just want to make sure you're familiar with the terms. And then what's D going to be, guys? Vertical shift. Okay, and this one can change the midline, and I'll show you what the midline is in a second. I mean, I think you guys can guess what a midline is, but I'll show you. A line in the middle. Shocker. Is it what? On the parent graph, yes. But if you have a vertical shift, it'll change. All right, guys, let me give you a little picture down here. All right, guys, so right in the middle here, that is your midline. It is the middle line, okay? Don't overthink it. Yeah.
So it's like change x-axis.
So it's a vertical shift. So let's say we had like +2 at the end. This would then move up 2, and do you see how your midline would have to move then to stay in the middle? Yep, that's what's in. Okay, and then the amplitude, guys, just to give you a visual, that is this distance here from the maximum to the midline or from the minimum up to the midline. That is your amplitude. It is like sound waves, exactly, yes. So guys, the period is one full cycle of the graph. Like, how long does it take before the graph would start repeating? And the way you find the period is always 2 pi divided by b. Okay? Your parent graphs, the period was 2 pi, right? That's one time around the circle. Hopefully that connects for you. That's how long until it starts repeating, meaning you'd be going around the circle again. If you have a B value, a horizontal stretch or compression, it'll change the period. Yeah. Then the period's 2 pi. Because there really is a B value, it's 1 if there's nothing written. Yeah. Like this, is that what you're talking about? Yep, that's your amplitude, whatever that distance is. Yep. get to try some graphs. Yeah, Myron.
Wait, so what was the full cycle be?
So until it starts repeating. So like, let's say, yeah, once around the circle, like for the sine graph, it looks like this.
Okay, so.
I could keep graphing, right?
Right.
But,
it's
so
not
that's
very
like-
hard.
2 cycles of it. Yeah, yep. Okay, guys, let's
Yeah.
back. Sure. Down there. You bet. That good? Are we ready? All right, our equation, the first one we're going to graph, y equals sine of x plus pi over 2, all that's in parentheses, minus 2. Okay, guys, let me walk you through it one step at a time. Please don't I know this piece, I'm doing it, and then go, wait, I didn't get that answer, and you didn't pay attention to the process, okay? So stick with me one step at a time to make sure you understand what we're doing all along the way, okay? Do we have any A or B value in this one? No. Okay, that's nice. When you don't have an A or a B value, the graph is really not too bad to do. What that means is that we can just label our X and Y axis just like we did for the parent graph. So I'm going to start by putting 1 and -1, 4 tick marks, pi over 2, pi, 3 pi over 2, and 2 pi. Yes, you have to write these every time because when the period changes, these will change. Okay, so it's part of your answer. And hopefully these aren't too hard to remember because they're just from the X and Y axis on your unit circle.
Can you just write the x-values on like the positive side of the axis?
I want you to write on both sides. I
Can
know.
it change in between angles?
Would what?
Like, just the negative side of the x-axis, that wouldn't be different from the positive side?
Nope. Sometimes I'll ask just for one period of the graph. And so if I do that, you would only have to label one side because you're only going to graph one side of it, okay? All right. I'm going to start by putting the dots for the parent graph up here. So this is your sine graph. Does that one start at 0, 0 or up at 1? Okay. So just put those dots, and if you have to look back, that's okay. You will get to a point where you just go, oh, okay, I've got my dots. Like, you don't even think about it. You just know your parent graph that well. I'm not going to connect them yet, but that's what I'm starting from, and then I can do my transformations. Okay. Everybody with me on the purple dots? That is just parent graph dots, okay? Okay, I've got 2 transformations happening. What are they? Left pi over 2 and down 2, okay? How far bar is pi over 2. Is it 1 tick mark, 2 tick marks? Okay, 1 tick mark. So I'm going to go 1 spot to the left and then 2 spots down. I am just going to take every purple dot and do that. Since I'm moving left, I'm going to start on the right side. Okay? So I'm going to go left, like this is what I'm doing. I'm going there, and then I'm going to go down to -2. Then I move on to the next dot, and I go left, down, that one will go all the way to -3. Left, down 2. Left, down 2. 2. Different colors are helpful so that you aren't just like, wow, I have 72 dots on my paper. Okay. And then I get to that last point, and it doesn't really have anywhere to go, right? The one that's at -2 pi, we're not actually going to move that one, okay? So once you get those dots, go ahead and stop. Show you what else you need to figure out. You guys see how I'm like missing an orange dot on this side of my graph? Right? There's nothing over here at +2 pi. 2 things you can do. You can just follow the pattern and go, okay, high, middle, low, middle, high, middle, low, middle, high, middle. Yeah, it's going to be the top. Or you can also look, the ends of your graph, the way we're graphing it, they're always going to match. Okay, so either way, I end up at 2 pi -1. Yeah, we're not going to graph this one that's off your grid. I want you to graph from -2 pi to 2 pi, okay? Or depending on whatever the period is. Yes.
Would we be graphing only 9 points on our text?
Yeah, unless I say 1 cycle of it, then you only have to graph 5. Do you see how that's 2 cycles of the graph? Okay. Yeah.
How do you indicate that the graph continues?
I mean, it's kind of weird to put arrows because, like, if, oops, not eraser. If I do like that, well, that kind of looks like it just keeps going down, which is not what it does. So we're just assuming, like, hey, we're just taking, like, a little snapshot of a window, and that's it. Like, we know it continues, but you don't have to show me that, okay? All right, let's try another one. Questions on that one? Sorry, before I write another one. Not too bad? Too bad? Too bad. What was too bad about it? There are lots of numbers. Those are numbers. All right, let's do this one. -2 cosine of x minus pi. One step at a time, guys. Don't get scared. All right, we definitely have an A value this time, right? Do I have a B value other than 1? Like, is there a change? No, okay. So I'm going to go ahead and do some tick marks. I am going to put up to 2 and -2 on the y-axis because I see that -2 out in front. But the x-axis will stay pi over 2, pi, 3 pi over 2, and 2. All right, I'm going to put the parent dots for cosine on here. You'll get to a point where you probably start with just doing -2 times the parent dots right away, but we'll do it in 2 steps since this is your first cosine graph. Cosine, remember, is the one that starts up here at 1, 0, -1, 0, 2. Follow your pattern and you've got your parent dots. I promise you will get much faster with the parent graph dots, okay? Okay, that -2 in front, what is that doing to your graph? What do you think? Okay, which values are we multiplying by 2? The y values. Could I just multiply them by -2 and do it all at once? Yeah, okay. It is a flip and a stretch, but you can combine that into one step and just multiply your y values by -2. Okay? So that's what this is doing. Multiply y values by -2. That is a flip and stretch. So this point that's at 1 is going to be down at -2. Are the ones at 0 going anywhere? No, because 0 times -2 is still 0. -1 will come up to +2. 0, -2. You got it now. Okay. But I'm not done at that point, so I'm still not going to connect them. I will go for different colors. Did you forget about your shift? Maybe. Okay. Lots of dots, yes. All right, guys, what is the shift on this one? Right by pi. And yes, pi is 2 tick marks. But guys, if I ever ask you to describe the shift, don't tell me right 2, okay? Because it's right by pi. You would count 2 tick marks to graph it, but don't say right by 2. Does that make sense? Okay. So since I'm going to the right, I would start on the left side of the graph, and I just have to move them 2 tick marks to the right. Remember, this is the green dots that I'm moving, so I move all the way over. And then can you fill in the pattern on the left end of your graph? You guys see it? Oh, okay. We're okay with the orange dots. So we're up here at 2, 0, -2, 0, 2, 0, -2, 0, 2. Okay. Yep, follow that pattern. Yes, and now you're like, can I draw yet? Yes. Well, I'm drawing it, you can check. You get it? I have no idea which ones your answers are. And be careful, those are pretty straight lines that you're connecting. Make sure it's curved, okay? it shouldn't look like angular mountain peaks, okay? Like rolling hills, that's what we have going on the graph.
But then does it go
Well, but if you actually graphed in between them, it graphed the root 3 over 2 and the root 2 over 2 and the 1/2, those are not linear, okay? I just don't make you plot all of those intermediate points because that would be very, very tedious. All right, questions on that one? I'm getting it? Maybe? Yeah.
On like 2 points, can't you just fill in the rest of the time?
Once you see the pattern, absolutely, yes. Just make sure you don't mess up those 2 points, if that's what you're basing everything. All right, let's do something with the b value this time. Y equals sine of 1/2 x.
And that's the only thing.
That's it. We're starting basic there because the period change is the trickiest part.
It's just the y-axis that changes it.
It's the x-axis. Isn't it with the x? Oh,
The X over 4.
the what?
Put X over 4 on
Not quite. I'll show you. I'll show you. You're thinking along the right lines, but you haven't flipped. Okay. Let's put our normal labels on here, or I'll put them, you don't have to write the normal ones, because we're going to change all of them. But let me just write at least the positive normal ones, and then we'll talk about how we're going to change those. Not quite. Is everybody okay with the b value is 1? We see that. Okay. The period is 2 pi divided by b. That's how you find the period. This is the first one we've had where the period's been anything other than 2 pi. So I have to do 2 pi divided by 1/2. What does that equal? 4 pi, right? Dividing by 1/2, flip, multiply. Okay. That means the period of my graph is 4 pi. Okay. I'm not going to make you graph it going out to 2 pi. If you were doing that, you'd see half of the graph by the time you got to 2 pi. The b value tells you how much of it you would see by the time you get to 2 pi. B is 1/2, you'd see half of the graph. We're going to go ahead and relabel the x-axis, so it's going to look just like the parent graph, but it's not, because that x-axis is going to have different labels. Okay, if I graphed it on here, it would look like that. That's not what we're going to do, okay? We're going to relabel and then put those points exactly where they were before. So just stick with me through this relabeling, and then we'll look at the graphs. So guys, 2 pi, what is 2 pi at the end of my graph here going to become? 4 pi, excellent. What's 3 pi over 2 going to be? 3 pi. You're finding all of these by dividing by 1/2, which is the same as multiplying by 2. So guys, what's pi going to become? 2 pi. And what is pi over 2? Okay, the other way you can look at it, guys, they will always be evenly spaced. Like if you get to the end and you have like pi over 8 and then 3 pi and 5 pi, like that did not go well, okay? Something is very off. They should be nice, evenly spaced values. I'll go over on the left side here, negative pi, 2 pi. Okay. We've relabeled, but nothing else is changing. So you're going to put those parent graph dots in the exact same position they were in originally. Like, you don't have to think about where they should be based on this change in the period. You've already accounted for that. So I know sine is the graph that starts at 0, 0. And then it goes up to 1. and 0, and down to -1 and 0. It looks the same. Do you see now why labeling the axis is so important? Because it completely changes what the graph is.
That's just the fun, right?
That's it. Yep, you're done.
But there would be transformations if there were more.
Yeah, if there were transformations, you do this part first. And then you're like, okay, now I'm going to shift it by pi to the left. So,
Once you relabel the graph, it's just like treat it like normal.
Mhm.
Just graph it the same.
exactly, like, great, new labels, but the dots look exactly the same and you do everything the same. Yes.
So the thing is the period, could you just think of multiplying the labels on whatever the
Yes.
C value is?
The reciprocal. Yes. Yeah, fair question.
You're creating, you're creating for the midline. Isn't it just the D value?
Yes.
And that's the remaining. Right there, it's
Earlier, but that's okay. All right.
So there weren't any like transformations in the paragraph, the period was changed.
Correct. That's the only thing that's different. Like if I graphed them together, you guys don't need to write this down. If I graphed, you know, only out to 2 pi, the parent graph, I'll do that in blue. And then the like stretched out graph, like there's the normal one. Here's what we graphed. Oops, almost. That's why we had to go all the way to 4 pi so that we could see the whole thing. Okay?
So in order to relabel the graph, you just divide all the parent graphs, like values, by the B value.
Yes. Yep. That's it. Okay. Let's try this. Y equals cosine in parentheses 2x minus pi over 2. And that's it. I didn't say that like that was the end, but it is the end. Okay, what is different this time? Yeah, but do you guys see how there's also like a phase shift happening? Like we have both of those things. You must rewrite this in factored form. So what that looks like. Anytime there's a coefficient on x, anytime you have that b value, factor it out. What does that pi over 2 become? Yes, good. Okay. So you have a b value of 2, and you have a phase shift right pi over 4. Okay? That's where we're going to do everything from. All right, so let's think about our labels. Y-axis, I'm just doing 1 and -1. So guys, what's the period of this graph? No? Just pi, yeah. Remember, it's 2 pi over b. What is the b value here?
2.
2, so 2 pi over 2 is just pi, okay? That is what this last tick mark will be.
I meant like its importance.
Okay. Sorry, I asked what the period was, so you were answering a different question. But yes, they are broken up by 4. So guys, that last one's pi. What's the third tick mark out going to be?
3 pi over 4.
Yes, 3 pi over 4. What about the next one?
2 over 2.
Pi over 2. And the first one?
Over 4.
Yes. Okay, and then we have those on the left. Are we getting the relabeling? Like we get how to do that? Take your originals, divide them by the b value. That's 4.
And so we just graph the parent, and then we'll come with it. Or just
Graph the parent, so I'll put parent dots next. Guys, it's cosine. Where does cosine start? Put 1, okay, and so we put these dots, I'll do these in purple. What's the only thing I have left to do now? Which way?
right.
How far? Pi over 4, and how many tick marks is pi over 4? 1 tick mark over. So I'm just taking each purple dot, I move it 1 spot to the right. And once you see the pattern, just go with it.
Wouldn't this be the same as if it was the sine of 2x?
Yes. So what we're going to get to eventually, like sine and cosine, they're the same graph, just shifted. Eventually, I'll give you the graph and you write the equation of it. Eventually, as in like next class, so very soon. But sometimes I'll say, okay, here's a graph, right? It has a sine equation, and write it as a cosine equation, or write 2 sine equations, you know, because you could be flipping and shifting or just shifting. So yes, they're all, it's just the same thing slid back and forth. Yep, exactly.
I'm guessing it's tangent graphs.
It's not bad, it just has asymptotes.
What? Oh, well.
Tangent, cotangent, secant, and cosecant all have asymptotes because they all have points where they're undefined on the circle. They're not, that's not for today, that's a later problem, okay? We have 5 minutes left. Let's actually try one of these writing equation ones. This will be the last thing. We'll see if we can squeeze it in. All right, write the equation. And we'll practice many more of these later. So I'll give you the graph. I'll give you part of a graph. So this is the point 0.03. Three pi over 4 negative 1. And 3 pi over 2, 3. So I give you a little piece of a graph, and I want you to try to write the equation of it. It's easiest as a cosine equation. All right, so I want you guys to try this. And we might have to come back to it next class. So think about all of those pieces you need. What are they? Mm-hmm. Yeah, sorry. And that's halfway in between those two. So I'm clearly not giving you all 5 points that we normally would grab. Yeah, once you have an answer, check with your neighbor. Oh. don't like your 2/3, you're close.
What do you mean?
So,
Oh, yeah.
what is the period of this?
It would be,
I'm just looking at the graph. What is, like, isn't this one cycle of the graph? And how far, like, how far
so would it be 3 pi
over
over 2?
right? Like, isn't that?
Oh, okay.
So the period we know is that, correct?
Uh-huh.
You're right.
So that 3 pi over 2, and then the p value for you.
Yeah. Would it not be 2 over 3? Or would it be 1 over 3? Oh wait, is it? 4 pi?
How do I solve for
Oh wait, hold on, sorry. 4 over 3. Okay.
that? Makes sense.
I'm confused. Wouldn't it be, this is like, wouldn't the full cycle be like,
I'm gonna start with you.
oh yeah. Okay, we were just given it.
I gave you a little
Okay, yeah.
nugget of it. Sometimes I might only give you like half of it.
Uh-huh.
All right, guys, we're almost out of time. Let me write it up here, and we'll talk about it next class, okay? It's 2 cosine of 4/3 x plus 1 is outside.
Yeah, I got that.
Okay. All right, guys. I am going to make homework available today, but I'm not going to make it due for a while because next week you don't have school Monday or Tuesday, and Wednesday is going to be a catch-up day, so I'm definitely going to give you time in class to work on that, and we can do some more practice on some of these. So it won't be due until the earliest next week on Wednesday, okay? So you've got lots of time.